Good evening. My name is Anita Solis, and this evening I'll be presenting the project I did for UrbanGear in regards to their inventory optimization for our Capstone class. We'll be going over an introduction of the problem, the methods that were used, prescribed action engine, the deliverable, and final tips and takeaways. UrbanGear is losing sales and customers daily due to a fundamental operational flaw. That is, our inability to have the right product in the right store at the right time. The problem manifests as empty shelves for bestsellers, which directly leads to lost sales, frustrated customers turning to competitors, and expensive logistical band-aids like emergency inter-store transfers. We are not just managing stock, we are managing risk. Risk to the revenue, the brand, and the customer relationships. The analysis suggests we are leaving up to 5% of potential monthly sales on the table. This project is a direct plan to reclaim it. For methods, our approach moves us from a reactive, intuition-based system to a proactive, intelligent one. It's built on three integrated layers: diagnostic, prescriptive, and actionable. We begin by diagnosing the root cause. Our analysis of 24 months of historical data revealed that demand is not uniform. It's hyperlocal. A best-selling athletic wear in our downtown store has completely different sales patterns than in a suburban mall, especially during promotional events. For the model, to capture it, we built and tested several machine learning models, ultimately selecting a gradient boosting regressor. This model excels at handling tabular data with complex nonlinear relationships. The key predictive features we engineered feature allows the model to understand the context of sales. So for temporal, we would be looking at the day of the week, the month, proximity to holidays, and a rolling trend. For the historical data, we looked at lagged sales, such as what sold last week, last month, last year. For our promotionals, we have a flagged indicator for promotion days combined with the magnitude of the past promotional lifts. For the product life cycle, this is where a SKU sits in a life cycle for the new, the core, and the end of life. And for our output, the model just doesn't give one number. It generates a probabilistic demand forecast for each SKU store combination for the next 4 to 8 weeks, allowing us to understand both the expected demand and its potential variability. For the prescriptive action engine, a forecast is a prediction, not a decision. Our prescriptive engine uses this forecast to make the optimal replenishment decisions. We modeled this as a stochastic inventory optimization problem. The logic is that the system calculates two critical numbers for every item in every store. Our dynamic reorder point is no longer a fixed number. It calculates as lead time forecast plus safety stock. The safety stock is not a guess. It's statistically derived based on the forecast error and our target service level, ensuring we meet 95% of demand without a stock out. For our optimal order quantity, when the inventory hits the rope, how much do we order? We use an adapted economic order quantity model that balances the cost of placing an order with the cost of holding inventory, all while aiming to meet the forecasted demand smoothly. The critical rule is that the system is explicitly programmed to prioritize direct warehouse to store replenishment. It will only suggest an interstore transfer as a last resort exception, and only if the cost-benefit analysis justifies it, fundamentally reversing our current costly practice. The deliverable. This is where insight becomes action. The dashboard, built in Power BI, is designed for speed and clarity. For the first view, we will have an at-risk heat map, which is a grid of stores versus the top SKUs, color-coded red, amber, green, based on the calculated days of stock remaining versus the lead time. Red items are predicted to stock out before the next replenishment truck arrives. This gives a 10-second company-wide health check. Our second view is of the prescriptive replenishment list. This is the primary tool for the inventory manager. It is filterable, sortable table that lists for a selected store or region the SKU and description, the current inventory level, dynamic reorder point, recommended order quantity from warehouse, the confidence score for the warehouse, and a single approve order button to send the recommendation directly to the procurement system. Our conclusion is that our diagnostic phase proved that our pain points stem from a static aggregated view of inventory. The solution requires granular, predictive, and automated decision support. We expect a direct lift in sales by capturing demand we currently miss, a sharp reduction in emergency transfer cost, and a rise in customer satisfaction scores as in-stock rates improve. For the future work, we will focus on closed-loop learning, which is feeding actual sales data back into the model to auto-tune its accuracy. We'll have a multi-echelon optimization, which is expanding the model to optimize distribution center inventory, not just store level. And for our markdown integration, we will be prescribing optimal markdown strategies for slow-moving stock identified by the same system. For final tips and key takeaways, the hardest technical hurdle was building the prescriptive bridge. Choosing the right safety stock formula, balancing statistical rigor with operational simplicity, was a profound challenge. It was moving beyond a textbook model to create one robust enough for real-world demand volatility. The most interesting revelation was the power of the singular source of truth dashboard. In the prototype testing, simply visualizing the days of stock metric changed perspective behavior immediately. It transforms inventory from an abstract list of numbers into a tangible timeline of risk, proving that elegant data presentation is as critical as the complex algorithms behind it. Thank you for listening to my presentation and interacting with me in class. I wish the best of luck to everybody. Thank you.